Hello everyone. In this video, I would like to go over solving for linear equations. Before I get to this equation, I would like to review what we have done in previous video. So in previous video, we are solving for an equation like this, okay? And even an equation that looks like this. So the basic concept of solving for a linear equation where you have x as the unknown is to isolate x by bringing x to one side of the equation. And what we do is we chose to leave x on the left-hand side. So that means whatever term involving the x, you need to bring it over to the left-hand side. Whatever term that not involving the x, you put it on the right-hand side. Okay, so this one will give you just one operations. That means you get rid of a 25 by subtract 25 on both sides. Then you have x on this side of the equation. Then perform this basic opposite operation in order to solve for x. Okay, solve for x means you just have one x. So for this question, you have involving another operations here. So before we can isolate, you check both sides to see what you can simplify. You see, this one you can simplify this term, and you can combine this term with x. And after you've done this, now you can perform the step of isolating the x. Alright, so for these questions, what you have is you see the brackets and x is inside the brackets. It means you have to apply the distributive rule. So what is the distributive rule? Distributive rule say that if you have a coefficient in front of a bracket, that means you can multiply this coefficient with each term inside the bracket. Alright? So you can write it as a times b plus a times c. So this is called the distributive rule. It's very important that we need to apply this distributive rule for this right-hand side of the equation before we can isolate the x. Because x is inside the bracket. Okay? So you cannot isolate x when leaving it inside the brackets like this. So the very first step, as soon as you see this, is to apply the distributive rule. So I'm going to draw the arrow showing that I will apply the distributive rule. So applying the distributive rule, I will have no more brackets left, right? Okay. So on this side, I cannot simplify. The left-hand side stay the same, but 4 times x will give me 4x. 4 times negative 2 will give me negative 8. And be careful when you apply distributive rule, you have to take this negative into consideration. So negative 2 times x, okay, so it will be negative 2x. And then negative 2 times negative 5 will give me positive 10. So now you see that no more brackets. With no more brackets, you can go ahead and combine the like terms. Of whatever you see on this side of the equation, you can combine it. Okay, that means we simplify, right? We simplify whatever we can on this side. So I can, what they call, collect the like term. So I have x and x here. I can collect these two like terms. So I will have 4 subtract 2. I will have the answer as 2x. Okay, so if I combine these two, negative 10, negative 8 plus 10, I should have the answer as positive 2. Okay, so you simplify your equation one step at a time. Now after this point, you go ask yourself, so the basic concept of solving for an equation is to isolate the x. And what side do you choose? You choose for x to be on the left-hand side of the equation. Therefore, you need to get rid of the 2x on this side. In order for you to get rid of the 2x on this side, you must subtract 2x. Okay, so let me give myself some space. So if I rewrite my equation like this, okay, you want to give yourself some space. So that means you are planning ahead. All right. So this is the exact same equation that I write, but I give myself some space because I know that I perform some operations here. So the first thing you do is take a look at the 2x, right? You don't want the 2x on this side, so you subtract the 2x. That means I must do the same thing on the other side. I subtract the 2x. And then at the same time, you see that you only want x on the left-hand side. You don't want the negative 12 to be here. So what you can do is you have to add the 12 in order to get rid of it. Then you do the same thing on the other side by add the 12. So subtract 2x on this side, do the same thing on the other side, plus 12, do the exact same thing on the other side. So now what I'm going to do is I see that cancel that, negative 12 plus 12 is gone, and I just have x left. You see? This one cancel with that. 2x subtract 2x is 0x, so I don't need to write anything here. And then I just have the number on this side of the equation. So in the end, I should have negative 7x equal to positive 14. Okay, 2 plus 12 is 14. So you can go ahead and perform this operation to have just one x left. And what do we see here? So that and that cancel. Therefore, x is equal to negative 2. Okay. The nice thing about solving for equation is we should check. Okay. So I'm going to write here that I'm going to check. That means I want to know if my left-hand side is equal to my right-hand side. Again, the concept of checking for the equation, for the solution, whether or not we get the correct solution, is to substitute x into the original equation. So the original equation given to us like this. So you don't want to substitute x into this step, or the final step. Because what happens if we make an error? That means we use our error to check another error. Okay, so therefore, it's always mandatory that you must substitute the solution of x into the original equation. So I want to make sure that I write the original equation correct. Okay, the original equation should be negative 5x subtract 12 equal to 4 times x minus 2 times x minus 5. Okay, so let's check if we actually write everything correct. 5x minus 12, 4x minus 2, minus 2x minus 5. And what we do next is I am going to substitute the negative 2 to where the x is. Alright, okay, so here's negative 2 and subtract 2 minus 2, and where the x is, I will put in the negative 2. Okay, so we double check, right? We double check. So this step that you see right here, so this particular step that you see, so I'm going to highlight it for you. This step is now the basic concept of order or operation. That means you have to perform BADMAS. Okay, perform BADMAS. So I will need to perform this operation first. That should give me positive 10, subtract 12. So this should give me negative 4, and I time that with 4. This should give me negative 7. Okay, so double check. We are going to follow BADMAS, multiplication first. Negative 5 times negative 2 give me positive 10. Rewrite this number. Whatever inside the brackets, I do this first. Negative 2 is negative 4. And then this is the multiplication. I do that after. And this one is negative 7. Negative 2, negative 5, negative 7. So the next step is to perform the multiplication. On this side of the equation, you can combine these two. Okay, I can combine these two. I should have negative 2 as the answer. But this one, 4 times negative 4 should give me negative 16. And don't forget, negative 2 times negative 7 should give me positive 14. And now you see that these two numbers combined, the operation of these two integers should give me negative 2. So now you can go ahead and conclude that your left-hand side is equal to the right-hand side. And then x is absolutely equal to the values that given that you have found up here as x equal to negative 2. And it's happened to be negative 2 equal to negative 2 on both sides. Okay, so up to this point, I would like to mention to everyone that once you encounter an equation like this, okay, if x is inside the brackets, the very first step is to remember that using distributive rule. So this is the very first step. Okay, the very first step is to apply the distributive rule. Because you cannot isolate x when x is inside the brackets. Alright, okay. So once you open up the bracket like this, you expand the term, you can combine, and then from here, you already know the basic concept of solving for linear equation, which is isolating the x. Okay? Alright, so I have noticed that in the previous video or this video, I tend to say left hand side, right hand side, and then I switch the order. I apologize for that. I think it's just a minor error, and it's an indication of old age. All right. Okay. Anyway, let me take a sip of tea, and then I will continue with this question. All right. Thank you. So at this point, you should have an idea how to perform this operations, right? You probably know all the steps, knowing what to do in order to solve for x in this equation. So in this equation, you have x inside the bracket, you have x inside the bracket, and they stay on both sides, all right? And you cannot combine any term here. The only step that you can perform right away is, again, the distributive rule. Okay, as soon as you see the brackets and x is inside the bracket, then remember distributive rule. The only one way to get rid of the bracket and bring x outside the bracket is performing the distributive rule. Okay, that means you take the coefficient in front of the bracket, multiply each term inside the bracket, and then you have no more brackets left. Alright, okay, so you see this? Negative 21. I need to multiply this inside the brackets. At the same time, I will take negative 17 and I multiply by each term inside the brackets. Alright, so that's what do we have? So we will have negative 21 times x will be negative 21x. Okay, negative 21 times negative 7, it should give me positive 147. Okay, be mindful that we are having the negative in front of the bracket and we multiply by a negative, therefore it turned into a positive. Then I want you to rewrite the 23, okay, plus the 23, and then we simplify in the next step. We do one step at a time. One step at a time, that means you only perform the distributive rule right here. So you distribute the term. Okay. So right here, I should have negative 17 times x. I should have negative 17x. Okay. Now, negative 17 times negative 9 should give me a positive value, which is positive 153. So be mindful of the negative in front of the coefficient. You have to take that negative into consideration when you distribute the term. So up to this point, you see what you can simplify on both sides. So this that you can simplify, right? Okay, so we still apply all the step that I provide to everyone. I don't want to skip any step here. Okay, so I will have negative 21x. When these two combine, I should get 170. I should have negative 17x. When these two integers combine, I should have positive 102. Okay, so use your calculator if you want to perform the operations of integer. Now up to this point, you see, you want to get rid of negative 17 and you want to get rid of 170. So I have negative 21x plus 170. I will give myself some room. Okay, so the first thing I do is I will add 17x. So I will add 17x on this side as well. You see that? Okay. Negative 17x, if you add 17x, it will be 0x, and you have no more x left on this side. Because you add 17x on the right-hand side of the equation, you must do the same thing on the left-hand side. And at the same time, I want to get rid of plus 170. That means I'm going to subtract 170. It means the same thing must be performed on the other side. Alright, so it's the same concept that we're repeating, and we know that we get rid of that because we have to perform the operation that serve our purpose. Okay, it serve our purpose that I subtract 170, I get rid of plus 170 on this side. Now this side of the equation, I only have the term with x left. Whatever I do on this side, I must do the exact same thing on the other side. Okay, so the logic of solving for linear equation is like that. So now I can combine these two. Okay, this should give me negative 4x. And on this side, combine these two numbers should give me negative 68. Okay, so now it's so simple that you can just divide both sides by negative 4. And what do we have left here? We have x is equal to 68 divided by 4, but we have negative divided by negative. I should have a positive value. So this should give me positive 17. All right. We are not finished yet, right? We have to check. Okay, so the left-hand side equal to the right-hand side. So again, I will make sure that I write down the correct equation, the original equation. The original equation is negative 21 x minus 7 plus 23 equal to negative 51 subtract 17 times x minus 9. Alright, so let's see if I write everything down correct. Negative 21x minus 7 plus 23 minus 51 subtract 17 x minus 9. Alright, okay, so where the x is, I will replace that by positive 17. So negative 21, so this will be 17. Okay, so where the x is, I will put it as 17. Okay, so as a positive value, I don't need to put a positive at the front. Okay, so now it gets into the concept of bad math. So we need to know what to do first. Okay, we need to know that I need to combine the term inside the brackets first. So that should give me 10. So this should give me 8. Okay, Also with bad math, this is multiplication and this is multiplication. So this should give me negative 210. This should give me negative 136. Okay, so still rewrite what I have on this side of the equation again. Now you can combine these two to see what happened. Negative 210 plus 23 will give me negative 187. So let's see if this two number will give me the same thing. So negative 51 subtract 136 will give me negative 187 as well. Alright, so at this point you can conclude that left hand side is equal to the right hand side. It means that you have the correct solution for x. In this case, x is equal to negative 17. And checking both sides, the two numbers are the same. Alright, so I hope you get the concept of performing the check step. Okay, that means you substitute x into the original equation, perform all the operation on one side, perform all the operation on the other side, and then in the end see if the two final results actually match with each other. Alright everyone, thank you very much. I think I have covered everything I need to cover, and I have said what I need to say, and I involve every single step, every single trick that I can think of to make solving for linear equation as clear as possible. Alright, so if you go back to the previous video and then you see that I have a review for everyone by asking everyone to simplify but not solving for anything, right? So in this case, it's a distributive rule, okay? Distributive rule. Multiply each term inside the bracket, then you have no more brackets left. So this is the distributive rule. Distributive rule is a very important concept in algebra. That means you take the coefficient in front of this and you multiply each term inside this bracket, or they expand it or distribute it, you will have no more brackets left. Okay, and then you combine the like term. I want to throw in this review before I asking everyone to solve for x. So when you solve for x, what is your basic concept? Is to isolate x. Isolate x, that means you can only have x on one side of the equations. And this is the simple operations because you only have one operation on this side of the equation, which you multiply by negative 3 to the x, right? So get rid of it, you divide it by negative 3 by using the opposite operations, okay? What is the opposite operation of multiplication? Is division. What is the opposite operation of division? Is multiplication, okay? And what is the opposite operation of addition? Is subtraction. What is the opposite operation of subtraction? Is addition. Okay, so I'm using the verb here. The verb means I describe the action. That means I multiply, I divide, I add, and then I subtract. So when I talk about negative and positive, it means I describe the integer. Okay, so throughout the entire lesson, for 2 videos, I kept talking about the adding the 5 or adding the 5 on this side or divided by negative 2. Okay, so I want you to be very clear of that. All I have done here is I apply that mass, same depth. I also apply the opposite operation. Okay, I never mentioned that I've changed the sign. Okay, if I say changing the sign, it will be confused because solving for equation perform step by step is always like this. Okay, so right here I said I divided by negative 2 because I only I divided by negative 2 to get rid of the multiplication of negative 2. I'm not changing any sign here, alright? Okay, I am only changing the operations, and I really want everyone to be clear of that because many students actually make a mistake that they divided by 2 instead of negative 2. Okay, because they kept thinking of changing the sign, but we are not changing any sign. We only perform the opposite operation. All right. So that's consistent throughout the entire two lesson. And I hope after this two video you are clear of what to do when you see a simple linear equation or a complicated linear equation, and then you need to solve for x. Okay. So solving for x, it will give you an equation that means you have the left hand side and the right hand side. And isolate the x, you always want to bring x over to the right hand side of the equation. But if you, I mean the left hand side of the equation, but if you want to leave x on the right hand side, it's absolutely fine. Okay? So in the end, what I meant by that, in the end, if you are having negative 2 equal to x, is express the exact same thing. Yeah, but we just want to be consistent, and that we isolate the x by bring x over to the left hand side of the equation. Again, if I mixed up between the left hand side and the right hand side, I apologize for that, and I just want to tell everyone that it's probably come because of age. Okay. All right. Thank you, everyone.